Earth is not the birthplace of life. It's really just the landing pad.
Exactly.
Welcome to the deep dive. If you're listening to this, you're looking for the signal in the cosmic noise. You want the universe-spanning astrophysics without all the dense academic jargon.
Right. We are keeping it accessible today.
Yeah, and today we are completely tearing down that classic primordial soup narrative. I mean, you know the one I'm talking about. A sterile, rocky planet, some volcanic lightning, a little puddle of warm chemicals, and then poof, a 1,000,000,000 lucky strike produces a single-celled organism.
It's the old lottery winner analogy.
Yeah, it's incredibly Earth-centric. It basically treats us like an isolated lottery winner sitting in this dead, empty casino of a universe.
Yeah.
But we are pulling from a really fascinating source text today titled 3641p, The Early Arrival of Life, alongside an analytical framework known as the Way of PoE.
And these sources are fantastic because they completely dismantle the idea of life as a random terrestrial fluke.
Totally. They propose this mechanism where the universe itself acts as the active forge for biological complexity.
We are entirely reframing the baseline assumption of astrophysics and biology here. Because the conventional view treats the universe as a passive vacuum, like just a vast, sterile stage where matter just occasionally bumps into itself.
Just dead rocks floating around.
Exactly.
Oh.
But the perspective we are investigating today flips that completely. It argues that the universe is highly active. It's structurally biased toward complexity.
Wow.
Yeah, and it was manufacturing the fundamental architecture of biology long before our solar system even, coalesced from the nebula.
Okay, let's unpack this. Because to really understand this cosmic origin story, we have to start way out in deep space.
Yeah.
Far away from any warm, comfortable planetary puddles.
Right, we have to look at the immense invisible scaffolding of the cosmos.
The extreme magnetic fields.
Yes. The framework of PoE posits that the true crucible for life wasn't water and rock at all. It was the intensely powerful magnetic fields found inside interstellar molecular clouds.
And around young stars, right?
Yeah, nascent stars. These fields permeate regions of space that are just incredibly dense with heavy elements and interstellar dust, specifically things like silicates and carbonaceous materials.
Basically the fundamental raw materials of organic chemistry.
That's right.
But, the crucial part isn't just that the elements are sitting there, it's what the magnetic fields actually do to them. Because the physics detailed in the source describes what happens to these tiny nanoparticles when they're suspended inside these magnetic force fields.
They don't just float randomly in a chaotic cloud.
Right. They self-organize. The immense magnetic pressure exerts this torque on the charged dust particles, forcing them to align, and they twist into these incredibly specific geometric configurations.
They form helical structures.
Which is wild. Helixes that basically mirror the physical morphology of the DNA molecule.
What's fascinating here is the underlying thermodynamic necessity of that shape. I mean, it isn't random chance at all.
It's not a fluke.
No, it's magnetic anisotropy. When you have charged nanoparticles moving through a highly structured magnetic field, the particles naturally seek the lowest possible energy state.
To kind of minimize the energy and resist the magnetic torque.
Right. So they align along the field lines, inevitably stacking and twisting into a helix.
That is amazing.
The fundamental shape of life, that twisting ladder, is a direct physical response to the most dominant forces in the universe, just trying to dissipate energy efficiently.
So if I'm picturing this mechanically, it's not just a kitchen mixing ingredients. So it's almost like the universe is an interstellar delivery kitchen. The magnetic fields are mixing the cosmic dough into these helical shapes, and comets are the delivery drivers dropping them off at Earth's doorstep. Wait, actually, let me try a different analogy. It's more like cymatics.
Oh, cymatics.
When you see a scientist run sound waves through a metal plate covered in sand, and the frequencies force the sand into perfect, complex geometric patterns.
That is a highly accurate way to visualize the physical mechanism.
So the magnetic field lines are the acoustic waves, the carbon dust is the sand, and the resulting pattern is the helix. The universe is literally vibrating the raw materials into the architecture of life.
It really is. The synergy at play here, the combined cooperative action of magnetic forces, charged particles, and thermodynamics, it drives matter away from chaos and towards self-organization.
A cosmic midwife.
Yes. This deep space environment is actively forging the pre-biological architecture.
Which is mind-blowing. But let's follow the physics here for a second. Okay, so the magnetic field forged this delicate molecular helix in a protostellar cloud. But deep space is a relentlessly hostile environment.
Extremely hostile.
I mean, it is flooded with galactic cosmic rays, ionizing radiation, and extreme ultraviolet light. That should shred those delicate carbon bonds instantly. So how does a fragile precursor to DNA survive long enough to reach a planet?
That requires a cosmic shield, which is where panspermia transitions from a theoretical concept to a mechanical necessity.
Panspermia, for those listening, is the concept that these pre-DNA molecules were transported to Earth via space debris.
Right, the hypothesis that the seeds of life are dispersed throughout the universe. But like you said, the delivery mechanism requires immense preservation.
Because space is brutal.
Yeah, but within these molecular clouds, temperatures are near absolute zero. So as these helical organics form, volatile gases like water, ammonia, and carbon monoxide just freeze right around them.
Oh, I see.
They encase the organic dust in thick mantles of amorphous ice.
So they are essentially cryopreserved.
Yes. And over millions of years, these ice-coated grains aggregate into larger bodies, comets and asteroids.
Right.
The ice and rock act as a massive Faraday cage and a radiation shield. The delicate molecular structures are buried deep within the core of a comet, perfectly protected from UV degradation and cosmic rays.
So they travel across the interstellar void in a state of deep dormancy.
Waiting for a gravitational collision with a young planet.
And that collision is where the timeline gets really aggressive. The sources point out that these seeds arrived on Earth via this intense cometary bombardment, and that sets the stage for the last universal common ancestor, or LUCA.
LUCA, right.
And for you listening, when we say LUCA, we mean the single biological node from which all subsequent life on Earth branched out.
Plants, bacteria, you, me.
We all trace back to this single cellular architecture.
And the geological and biological records suggest LUCA emerged during the Hadean Eon, which was just a few 100 million years after the Earth formed.
Which is nothing in geological time.
In the grand scale of planetary evolution, that is practically instantaneous, the crust had barely solidified.
Wait, okay, this is where I have to push back on the framework's idea of synergy. Because if we look at the Hadean Eon, we aren't looking at a welcoming nursery. We are talking about a tumultuous, violently inhospitable nightmare.
It was definitely chaotic.
Right. The early Earth was teeming with constant volcanic activity, an atmosphere choked with toxic gases, and oceans that are practically boiling under a massive greenhouse effect, all while being continuously bombarded by asteroids.
True.
We know from basic chemistry that extreme heat denatures complex molecules. It breaks apart DNA. If the Earth was essentially a chaotic volcanic blender, wouldn't that destroy these fragile pre-DNA molecules? How is dropping a delicate molecular seed into a hurricane an example of the universe being hospitable?
That's a very fair question. The Hadean Eon was undeniably violent, but we need to reframe our understanding of what a catalyst actually requires.
Okay.
A calm, peaceful garden doesn't force chemical evolution, it encourages stagnation. Synergy, in the context of these sources, is about providing immense, concentrated energetic differentials.
So the violence is actually helpful.
Yes. You bring up the heat denaturing molecules, which is true at the surface, but the continuous cometary bombardment delivered these organic precursors into early, deep oceans. And at the bottom of those oceans, you have hydrothermal vents.
Oh, where the crushing atmospheric pressure of the early Earth kept the water liquid despite the extreme temperatures.
Exactly the mechanism.
Yeah.
At those vents, you have alkaline fluids meeting acidic, iron-rich seawater.
Right.
This creates a massive electrochemical gradient. It's a literal battery powered by the Earth's geothermal heat.
Wow.
The chaotic volcanic nature of the early Earth provided the exact proton gradients necessary to drive the synthesis of ATP, which is the energy currency of life.
Okay, so the synergy isn't about safety.
No, it's about the universe providing the precise combination of heat, pressure, and chemical imbalance needed to force that dormant cosmic seed to wake up, adapt, and metabolize.
So the volcanic blender isn't destroying the ingredients. The extreme pressure and geothermal heat at the bottom of the ocean are acting like an anvil and hammer, basically forging those early helixes into something that can actively harness energy.
Exactly. The early arrival of LUCA, despite the chaos, is proof of life's incredible resilience.
Yeah, that makes sense.
It shows that the spark of life is incredibly robust when given the right energetic catalysts. Physics, matter, and energy conspire to create environments where life is compelled to take root.
Transforming our view of the universe from a sterile void to a fertile ground.
The text argues this permanently alters our worldview. The chaos of early Earth wasn't a barrier, It was the essential thermodynamic engine that activated those pre-DNA molecules.
That drastically changes how you view our own existence. It means biology is stubborn. It is a driven process. And that forces us to confront a massive philosophical question about the nature of the physics involved.
Right.
Because if life survives and thrives against all those odds, driven by magnetic fields and hydrothermal vents, we have to ask, was this just an incredibly lucky roll of the dice, or is the game rigged in favor of life from the very beginning?
The analytical response to the way of PoE confronts this directly by explicitly rejecting the whole fluke theory. The mathematical probability of life emerging from purely random, unguided collisions of atoms is practically zero.
So the framework argues against an indifferent universe. Completely.
Here's where it gets really interesting, because the framework uses the phrase cosmic fine-tuning. It argues that the laws of physics, the properties of matter, and the distribution of heavy elements aren't random at all. They actively conspire to manifest consciousness.
Yes.
But I want to clarify the line between physics and purpose here. If the universe has an inherent purpose to manifest consciousness, does that mean the universe itself possesses a form of intention, like a conscious mind planning things out? Or is it just that the raw mathematical laws of physics are perfectly dialed in to force complexity to happen?
It's a great distinction. The analytical framework walks a very elegant line regarding teleology, the explanation of phenomena by the purpose they serve.
Okay.
It doesn't demand an anthropomorphic conscious entity pulling levers behind the curtain.
Okay.
Instead, it suggests that intention is woven into the very fabric of reality as a structural thermodynamic imperative.
Interesting.
Consider the second law of thermodynamics. Entropy always increases. The universe seeks to dissipate energy.
Right, things tend toward disorder. However, biological complexity is surprisingly one of the most efficient ways to dissipate energy. A living organism processes and disperses energy far more effectively than, say, a static rock.
Oh, wow. So by building complex life, the universe is actually obeying its own thermodynamic laws more efficiently.
Precisely. The way of PoE suggests that the tendency toward complexity, toward life, and ultimately toward consciousness is a fundamental physical law, much like gravity.
So it's inevitable.
Gravity doesn't intend to pull an apple to the ground in a conscious way, right?
Yeah.
But the curvature of space-time dictates that it inevitably will.
Right.
Similarly, the laws of chemistry and physics dictate that matter will self-organize to dissipate energy, leading inevitably to life. It's a cosmic imperative.
The universe can't help but make life the same way a star can't help but undergo nuclear fusion. It's simply what the machinery is built to do.
And understanding that demands a radical shift in human self-perception. We have to stop viewing ourselves as isolated biological anomalies trapped on a lonely rock.
We are beneficiaries of a cosmic inheritance.
Exactly.
Yeah.
One that spans billions of years and billions of light years.
Yeah.
The iron in our blood, the helical shape of our DNA, the metabolic tenacity of our cellular ancestors. It is all part of a vast, interconnected thermodynamic web.
We are quite literally the universe experiencing itself through a localized lens of consciousness.
Beautifully put.
Which brings us to the practical, real-world ripple effect of this knowledge. Because if the universe is universally fine-tuned to create and spread life, if panspermia is an active, ongoing mechanical process happening everywhere, that completely changes two massive things for you and me.
How we look up at the stars and how we look down at our own planet.
Exactly.
If we connect this to the bigger picture, our search for extraterrestrial life has to evolve immediately. For decades, our search parameters have been incredibly terrestrial biased.
Right, we just look for Earth clones.
We look for the Goldilocks zones. Planets with liquid water, oxygen-rich atmospheres, and mild climates. We look for Earth 2.0, but if the building blocks of life are ubiquitous throughout the cosmos, forged in intense magnetic fields and spread by cryopreserving comets, well, biology could be taking root in environments we previously dismissed as completely sterile.
So what does this all mean for the listener and for the actual mechanics of space exploration? If life is meant to be everywhere, have we been looking for aliens the wrong way by only looking for Earth-like planets? Should we be looking at those intense magnetic fields instead?
The mission profiles definitely need to expand. We should be conducting spectroscopy on interstellar dust clouds not just for elemental composition, but for the complex pre-biological architecture.
Yeah, look for the helixes.
And we should view the ice moons in our own solar system, like Europa or Enceladus, not just as potential habitats, but as potential receiving grounds for panspermia.
Wow, that opens up the mathematical probability that the signatures of life are far more common than we ever dared to hope.
It really does. But equally critical is what this realization demands of us regarding our own biosphere on Earth.
Yeah, the sources get very specific about our responsibilities right here. They argue that this realization should spark deep humility. We are not the masters of the universe sitting at the top of an isolated evolutionary ladder. We are its humble, conscious outputs.
The framework calls for a profound sense of stewardship. When you trace the physical causality of your existence, from magnetic fields organizing charged nanoparticles, to comets acting as radiation shields across the void, to LUCA surviving the extreme pressure of a volcanic early Earth, you recognize a cosmic interconnectedness.
Right.
Recognizing that interconnectedness means acknowledging that our actions have consequences far beyond our individual lives.
I love the specific phrasing used in the analysis. It calls us conscious co-creators of reality.
It's a very powerful term.
That is such an empowering, active title. We aren't just a passive endpoint of this evolutionary line. We are active participants operating the machinery right now. It means choosing to live sustainably, respecting the immense diversity of life on Earth, because all of it shares that same incredible cosmic journey that we do.
We are all made of the same interstellar, magnetically aligned dust.
Yeah.
Shifting our perspective from one of isolation to one of unity fundamentally alters human behavior. If a civilization views itself as separate from nature, it exploits its environment for short-term thermodynamic gains.
Which is kind of what we've been doing.
Unfortunately, yes. But if a civilization views itself as an integral conscious node in a vast, intricate web of life woven together by physical synergy, it protects its biosphere. Sustainability is no longer just an environmental policy. It becomes a cosmic responsibility.
We are participating in the ongoing biological evolution of the cosmos itself. It really is a breathtaking cascade of physics when you lay it all out. I mean, we started this deep dive talking about the molecular mechanics of nanoparticles suspended in deep space.
Watching them twist into the shape of DNA under the immense pressure of extreme magnetic fields.
Right. And then we tracked the physical survival of those delicate helixes as they were cryopreserved inside comets, launched across the freezing void of space, only to be slammed into the violent pressurized hydrothermal vents of early Earth.
And from those harsh energetic gradients, LUCA emerged, proving that life is not a fragile statistical anomaly, but a resilient, inevitable thermodynamic outcome of a universe structurally wired to compel its creation.
A universe acting as a cosmic forge, guiding matter toward complexity, toward consciousness, toward us. We are not a fluke. We are a cosmic imperative.
Our technological capability to understand this process implies a duty to honor that inheritance, both in how we manage our planetary biosphere and in how we conduct ourselves as we reach out into the stars.
Which leaves me with one final practical thought for you to chew on. We've established the mechanics of panspermia, that life arrived here from the stars, driven by a physical imperative to dissipate energy and spread complexity. And the analytical framework clearly states that humans are now the conscious co-creators of reality, playing a role in the evolution of the cosmos.
Yes.
Well, look at our space programs right now. We are launching probes, satellites, and rovers out into the solar system and beyond. Voyager is in interstellar space. We're planning missions to Mars and the outer moons.
Yeah, that's true.
And despite our best sterilization protocols, we know microbes survive on the outside of the International Space Station. If life is a universal imperative driven to spread and humans are its conscious agents, could Earth itself now be transitioning into a cosmic midwife?
Oh, wow.
Are we, through our own space exploration and satellites, destined to be the delivery mechanism that seeds the next chaotic young worlds with the building blocks of life?
It completely reframes our expanding presence in the solar system from exploration to active dissemination.
We might just be the universe figuring out a faster, technological way to spread the seeds. Thank you for taking this deep dive into the source material with us. The next time you step outside and look up at the night sky, don't think of it as an empty, sterile casino where Earth just happened to win a lucky bet. Think of it as the active, vibrating workshop where your biological architecture was forged with a whole new sense of belonging. Catch you on the next deep dive.